is the Robinson annulation. Okay, and this is a ring forming reaction. So you might want to get a new reaction sheet. This uses a Michael reaction, and that Michael acceptor, in particular it's a Michael acceptor, is called the MVK. This is methyl vinyl ketone. So what does that look like? It looks like this. So this is a methyl, there's your methyl, vinyl, there's your vinyl, and ketone, there's your ketone. Okay, so you use a methyl vinyl ketone, and then you have some form of ketone. So plus MVK in base, so sodium hydroxide, you're going to get a Robinson annulation. So you use some form of ketone, you use the MVK, those are your substrates, this is your reagent, base, and you're going to get a Robinson annulation. So it's going to be ring forming. So let's look at that reaction. CH3, and we're going to react this with methyl vinyl ketone, MVK, and we're going to throw in some base. Now the first thing that's going to happen is you're going to form the enolate with your ketone. Okay, remember this is a Michael acceptor. The MVK is a Michael acceptor. Okay, so that means when you have this 1, 2, 3, 4 system, this is a delta positive here at the 4. So this is going to be your electrophile. So the first thing we're going to do is we're going to do our enolate. And so we go ahead and take this hydrogen here, and you form your enolate. I'm going to do my little monkey face. Okay. And then this is going to be attack the MVK. So we'll add that on. Okay, we're going to do 1. This goes here. That's 4, 3. That's 4. This is 3. This is 2. Okay, and looks like that. And between the 3 and the 2, you get the double bond here. And then, of course, that gets protonated to form an enolate. 4, 3, 2, 1, OH, and then we tautomerize, and so when you add this together in base, this is the first thing that happens. You form your enolate, and I need more space here. All right. Four, 3, 1, 2, 3, 4. 1, 2, 3, 4. Okay, so this is what we formed so far. And now you still have base, and it's going to form a ring, and this is going to be now your electrophile. Okay, so this ketone that was your nucleophile is now your electrophile, and we're going to form a six-membered ring. So 1, 2, 3, 4, 5, 6. So I do the 1, 2, 3, 4, 5, 6. And I go ahead and just draw my electrophile like that. This is going to make that, it's going to deprotonate to make your enolate there. And then this is going to come here, attack that electrophile. And this is an aldol condensation, okay? So I'm going to go ahead and keep the CH3 here. This is going to come up and make the O minus. And then we have, that's 5. This is 6. So we're going to do another six-membered ring. 5, 4, 3, 2, 1. And on the 2, you have your ketone. Okay, so this was your alpha carbon. There's your alpha there. This has become your beta. This is your beta. And then, of course, in the aldol that gets protonated, OH, there's your alpha, there's your beta, okay? And then with heat, you're going to lose water. This is an E1CB mechanism. So you're going to lose that hydrogen, you're going to lose water, and you're going to make an alpha beta unsaturated product. There's your alpha, there's your beta. So there's your double bond. Okay? And that is the Robinson annulation. So let's review. Okay? It's going to make a ring. That's ring forming. You use the methyl vinyl ketone most often. So your first step, this is a Michael acceptor plus a ketone. Okay? Ketone is going to be your enolate. This is going to be your nucleophile. You can say that's the Michael donor. And it's going to attack your Michael acceptor. You're going to use sodium hydroxide base. First thing you're going to do is you're going to do a Michael addition. So your enolate will add to carbon number 4, delta positive of the methyl vinyl ketone. Then you're going to be getting a diketone product. Okay, so that's step 1. Step 2, you had a diketone and you generated an enolate to form a six-membered ring. And this was an aldol. So you finish up with an aldol condensation and it formed an alpha beta unsaturated carbonyl product that was fused ring. Okay, so you made a fused ring. So that's the summary. Now, let me give you a reaction. I tell you what I'll do is I will work another one. I will give this to you, and then you have to figure out the starting materials. Okay, so here you go. This is a Robinson annulation reaction. Okay, so we're going to do a retrosynthesis. So what I want you to do is I want you to label your alpha, beta, and put a line through it. Okay, and so then we're going to do that. We're going to break it down. Okay, so the beta, ketone. You see that? We keep the ring here, A lot of people miss this a lot of times. So I kind of even draw it the same way, right? 1, 2, 3, 1, 2, 3, 4. Then we have a carbonyl, and then we have a CH3. Okay? So this is our diketone. Now, how did we form the diketone? Okay, it came from a methyl vinyl ketone. So let's draw the methyl vinyl ketone. This is your methyl vinyl ketone. Okay, so let's see where those pieces are. Well, I guess it's not exactly a methyl vinyl ketone. It doesn't have to be. Okay, so let's look at this. This is your alpha. Okay, and this is your new bond. And this is your beta. So there's your bonds. And so this is 1, 2, 3, 4. 1, 2, 3, 4. And so if we break the other one, these are your starting materials. Okay, because that's your alpha. All right, and you put this in base. So what I would like for you to do is two things. I would like for you to show me, this is for your online POGL, show me the mechanism to make the product shown here. So I've given you the first step in base. You show that mechanism that gets you this product here, and then show me the mechanism to go from your diketone to your Robinson annulation reaction. And then the second thing is I want you to break this one down. And I want you to show me the starting materials for this one. And then you can also work it forward. And I want you to break this one down. I want you to do a retro synthesis for this Robinson product. And I want to see those starting materials.